Okay, this is called applied quadratics. And basically, they're going to be word problems, applications, that have quadratics in them. And the cool part is you don't have to do completing the square in this, ever. And you don't have to do the quadratic formula, ever, because your calculator can do those things. All right, so let's start by going here. When does a parabola open upwards? Basically, it opens up when a is positive. Okay, so this would be like a normal parabola that's positive in front. Does that ring a bell for you? All right, some terminology that you need to understand. These are called the x-intercepts, but they're also called the whats? The zeros, the solutions, and one more thing, the roots. All right, so what your calculator calls them, and this is probably the most important thing, the calculator does not call them the x-intercepts. It calls them the zeros. So if you want to find these spots on a calculator, you got to go to the menu and find the thing called zeros. All right. Do you have a calculator? You do. Good. Okay. All right. Stay with me, please. All right. So I want you to begin with typing in this equation right here, x squared plus 3x minus 7, and I will too, and then we'll see what we get. I'm going to pause for a second here. Traxler, once you get done typing it on yours, I want you to type it in on mine, up here. Okay? You're just going to type, just like touch the screen, all right? And pause for a second. All right, my graph looked kind of funny when I put it in there, so I'm looking at my window, and holy cow, I have my Y max way up here at 200. Now, if you ever want to just completely reset the window, you do something called Zoom 6. And it resets your window to the standard window. So if your window was all weird and you couldn't see your picture nicely, do a Zoom 6. Okay, that's all meant to fit really nicely on your graph right now with the standard window. Now, when we do another problem, we might have to move our window up or down, and that's important to know how to do that. So if I needed to see higher on the graph, that would be a Y maximum to see higher. Higher is Y. If I want to go further to the right, that would be an X maximum. All right, so anyway, I'm going to get back to my graph now. Now there's some important spots on this graph, and I need to teach you how to find a few things. These spots right there are called the roots, the x-intercepts, the solutions, and the most important one, the zeros. Why do I say most important? Because to find the zeros, you have to know that word. Go to second, calculate. It's right above trace. Second, calculate. It's right above the trace button. Okay? And now the zero. Go down to 0. Enter. Second, calculate the zeros. Okay. Now, it should say the word left bound. Everybody move your little spider thing until it is to the left of our 0 that we were looking at. This is the 0 I'm talking about working on right now. So I'm getting to the left of it. Am I above it? Yes, but I'm also to the left of it. I know some people get confused about it, but wait a minute, you're not to the left, you're above. Yeah, I'm to the left and I'm above. Okay, so I'm to the left of it. I hit enter. My calculator puts in a neat old little line down there. That's what the new calculators do, and it makes it just a little easier to read. Okay, but you don't probably have that. You probably just have the little triangle up at the top. And it's saying we want the boundaries between which we are going to find our 0. So now you go to the right of it and do the right boundary. And I hit enter. Now, do you get our 0 is between those two lines? Or in your case, between the little two triangles that it put on there? Now it says guess. The last one is always get right on top of it. See, I'm as close to on top of it as I can be. And then I hit enter. And now it calculates it exactly and says that that 0 is at negative 4.54. Raise your hand if you got the same thing. Okay, good. Yours didn't work. I want to assign you people to check with right now. Check, pausing. All right, so I'm going to show you one more time this process, and everybody please do this with me. We're going to calculate, use the calculator, second calculate, which is right above trace, the 0. Now we're going to go to the other one. Okay, so you're going to arrow and get, you want to be just to the left of this other 0, the other x-intercept. And now I am to the left of it. Those people that have trouble with your lefts and right, the left is the bus driver's side. That's what they're telling the little kids in the elementary schools now. The left is the bus driver's side. And if you look from the back of the bus and you look up there, if you're in Britain, that would mess you up pretty bad because the bus driver's side is the other side. But if you're in the United States, the bus driver's out on the left side. Anyway, there, I got my left side, I got my right side. Now it says guess. That means go right on top of where the root is and hit enter. There we go. Make sure yours says the same thing as your partner. Compare. Sometimes people don't want to admit they don't know how to do it, but we need them to know that they're doing it wrong. Second, calculate the 0. Did you guys all have it? Is anybody stuck?
Yeah, mine's saying error as well.
All right, go to your y equals screen. Go to your y equals screen. I want to see what your equations say. All right, that's okay. So go back to the graph. Now go second, calculate 0. Now go to the left of it. A little further to the left of it would be good. Hit enter. Now get to the right of your 0. A little further to the right of it. Hit enter. Now get right on top of your 0 and hit enter. That is it. Did you get that too? All right, good. Anybody not getting it or whatever? Okay, yes. Okay, let me look. That looks good. Hit graph. All right, do you know how to do this?
Yeah.
Okay, then help her. So, okay, so go second, calculate the what? Okay, you help her through it now. Let me watch you and I'll see if you're doing it right.
Okay, so you go to the left of it and then press enter. And then you go to the right of it. And then press enter. And then go right up.
There you go. Good. How about you?
Yeah, mine like is right. It never goes right on top.
Okay, I think your left and your right are not in the right spot. Because you're not far enough to the left of it and you're not far enough to the right of it. Start over again. Go second, calculate 0. And then get to the, show me where you think to the left of your 0 is. That is to the left, okay.
It goes like right here.
Okay, go a little further to the left. I'm just speculating what could be wrong. Go to the right of it and go fairways to the right of it. And I can't see, turn it a little bit. Okay, now that looks good. Now go right on top of it and hit enter.
Yeah, like it's not right on
It doesn't have to be, it's perfect, close enough. There you go.
Oh.
You got it. Okay, good. So, now let's, if you got the 1.54, I think you get the zeros. Now, the other thing you got to be able to find is the minimum or the max. What's that also known as? The vertex, that's right. We don't have to go through that awful, like, complete the square process to get the vertex. We can just get to the vertex by arrowing, oh, sorry, second, calculate the vertex. Wait a minute, it doesn't have a vertex. It has a minimum or a maximum. On our graph, we had a minimum, so we go minimum, enter. Now, left boundary, once again, you got to get to the left of it. I'm going to go down here. I know that's my spot right there, but I'm going to get to the left of it. I'm going to hit enter. I'm going to get to the right of it. I'm going to hit enter. I'm going to get right on top of it. And the third enter gives you the answer, which is negative 1.49999. Okay, everybody see if you can do that process. Compare with the kid next to you. Remember, your job to walk them through it. If they aren't doing it right, walk them through it. Tell them exactly what to push. I'll pause for a second while we do that. Okay, I think we got people up to speed on that one. Those are the main spots, the roots and the vertex. And now let's actually just do a problem. So everybody go to the next page on our notes. These are like written out in case you are struggling at home. You want to look through these notes more carefully, and it's telling you how to find the vertex, how to find the x-intercepts, but I walked you through that already. So let's talk about what these things in the equation mean. Get to the one that says projectile motion equation. Now I know you guys do one of these that's kind of like this in science, but ours is slightly different. It's not like either one of us is right or wrong. One of the formulas is just more detailed than the other. So This is the velocity, how fast the thing is moving when you launch it. This is the initial height, the starting height of your thing. Do you get that if I throw this marker up in the air, that my starting height would be wherever I'm holding it when I start? Okay? And the starting height is also known as the y-intercept. Doesn't the y-intercept normally go right there? Yes, it does. Okay? And then the last thing is this, which is our gravitational constant, and that basically means this negative means your parabola is going to be upside down, which makes sense because on the Earth, when you throw something up in the air, it comes back down again. So this is like your starting point, your y-intercept, and then the thing goes up in the air, hits its maximum, and then it comes down and hits the ground. And those are our key points. This one's called a max. There's a spot on the second calculate menu for that. This one's called the zero. There's a spot, that was the one we did a second ago, a second calculate the minimum, or in this case we do second calculate maximum. And then this is second calculate zero. You get to the left of it, get to the right of it, get right on top of it. All right, so that's the maximum and the zero. And there's one other thing. If you want to spot along here somewhere, like at time 3 seconds, you just go second calculate a value. So those are the 3 words you need on the calculator. Min or max, zero, and if you're somewhere not at these 2 spots, not here and not here, then you're probably doing a value. And that's where you say like x equals 3, like time is 3 seconds. Where is the ball? Okay, so remember we do have a couple days to learn this. We have today and then tomorrow to learn it, Monday to review it, and then we have a quiz on this on Tuesday of next week. All right, at least that's the way we have it presently planned. All right, so I want you to take a look at this equation. Do you remember from looking, well, the notes are right on the same page here. What is the velocity in that one? It's easy, just tell me the number verbally. 15, good. And then this next one, what's the initial height? That's the starting height, that's the y-intercept, it's 98. So in my picture, this would have been right here, from here to here, that would have been 98. Okay? And write an equation based on the information given. So that means I know this equation is going to always start like this. H of t, or you could just say y, equals, and then negative 4.9, and that's because on Earth, that's a gravitational constant for Earth. If you throw a ball up on the moon, do you get that it would not come down as fast? Because it doesn't have as much gravity. You can actually throw a ball up in the air on the moon and have it go way up there and then slowly come back down again. All right. And they actually did hit golf balls on the moon. Isn't that a cool idea? That'd be one of the little benefits of being an astronaut. Okay, so what's the initial height? 98, we had that one already. So that's initial height here of 7.6. So where do I put that? At the end of my equation. So I haven't done my velocity part yet. At the end of my equation, it's 7.6. And the velocity of 4, that just means plus 4. And what do I need? What's missing? T. Good. All right, so all I have to do is stick these numbers into an equation. It's easy peasy. There's your height, your initial height. There is your velocity. And this is a gravitational constant. Okay, example 6. An object has an initial velocity of 70, and the object starts on the ground, which would imply its height is a what? 0 is correct. Okay, write that equation for me. You can use y equals if you want. I'm going to have you turn it my way, and I'll tell you if you did it right. You zoom in on the last part of the equation, because it's going to be hard to see them. That one's right. That one's right. That one's right. Y equals, and you'll have it. Right. 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 Need a y equals. Right. 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 And yeah, that's okay. Some people plus 0 at the end, but you don't have to. Good. Some people had the negative missing on their 4.9. Good. You get a negative on that, 4.9, because we know on their parabola to be upside down. All right, good. Now, how to find a specific height at a given time. So basically, this is where you got a picture like this. You got your thing being launched from initial height of here, goes up in the air and comes back down again. And this is when it hits the ground. Let me clarify that. A lot of people get screwed up in their head and they start thinking this is how far the ball is away from them when it hits the ground. It's not. This is time down here. Time versus height. So this is how long it took till it hit the ground. Okay? But what they're talking about here is the specific height at a given time. That means like you're like right here. They say when, or no, they say where was the ball at time 3 seconds? Well, then you go second calculate the zero. No, the value, sorry. The value. All right, so let's put one of these into our calculator. Everybody type this puppy in right there. Nope, wait a minute. Nope, not that one. Sorry. I'm going to give you a, we'll do a different problem together. Let's do that one. Everybody type in that equation, negative 4.9t squared plus 55t plus 63. I'll pause for a second while we type that in. Okay, I've got it typed in, negative 4.9x squared plus 55. I have an x squared in there. Sorry, I got to fix that. Delete that out of there. Okay, plus 63. But my graph doesn't show anything. That's because I'm looking at only out to 10 in every direction. Where is the graph? It's way up there because remember our maximum height, or our like starting height is 63. So it's way higher. So everybody go to Window, and we want to make this thing go higher. Is that an X or a Y thing? Y controls the rise, so that's a Y thing. Everybody go to your Y max, and if it starts at 63, it's going to go higher than that. Let's make it like 100 max. And just make one change at a time and hit your graph and see what happens. Okay, my graph now goes way up, but still not quite high enough. Can I even see it coming back down again? Nope. So I should definitely go up higher, and maybe I should go further to the right. So I go to the window. I'm going to change my Y max to maybe 200 now. And my X, that's to the right. Maybe I'll make that like 50. I don't know. I'm just going to try it. And I see what happens. Can I see it now? Ooh, I can see it a lot better. Still can't quite see it all the way to the top, so I better go back one more time and go to my window. You get how you just have to play with this? You aren't going to know for sure. Just try it and see if you're getting closer. Now I'm going to make that like 300. 250 would have probably been fine. All right, and then I go graph. Cool. I've got it. And do you get the important spots are right there. It's called the y-intercept or the initial height. Right there. That's called a maximum or a min. What's this one? Maximum. And last is this spot, which is the 0, which is when it hits the ground. Okay? I want to show you the other kind, the value. Do you get that I don't know just automatically where this thing is after 4 seconds or 5 or 6? So how do I find it after, let's say, 7 seconds? Everybody right now go to second calculate. Do this with me. Second calculate a value. It's the very top one. The TI people put these in the order that they think they're going to get used. Obviously, they think value should be used a lot because they have it as their number one thing. Okay? So now it pops up an x equals blinky. X is time in the context of this graph. The ball's going up in the air over a certain time. So at 7 seconds, x equals what? Say it. 7. All right, good. So there we go. That was second calculated value. I'm going to come around and make sure that your calculator says 207.9. Okay, I think you've learned the main things that you needed to learn. if I asked you to find how high this ball went, everybody right now, use your skills. It's under second calculate. Find how high this ball went. Pause for a second while you try that. This is not the same answer. The answer is not 207.9. Otherwise, you're doing the wrong question. Pausing while you do it. Okay, so who's got the height? What was it? Yes, sir.
5.61.
All right. Anybody agree with him? Raise your hand if you had the same thing as he did. All right, that's called second calculate the maximum. I'm just going to do it really quick to show people at home how you do it. First, you get to the left of it. Enter. Then you get to the right of it. And your calculators probably don't have the little neato dotted lines on them, but that's the newest operating system. The last thing says guess. You get right on top, hit enter, and then it says 5.61 and 217. Do you get that that's a time and a height? The time is 5.61, and the height is 217 feet. Does that make sense? All right. Now let's go to second calculate the when it hit the ground. That's called the zero. Enter. I get to the left of my zero spot. I'm to the left of it. I'm hitting enter. I'm getting to the right of it. I'm hitting enter. And then I'm getting right on top of the zero spot, and I'm really close. That's close enough. You never get perfect. The perfect is after you hit enter. And it says 12.27. That means the ball was in the air for 12.27 seconds. Raise your hand if you had that right too. Okay, good. So the good part is you get to use calculators. The bad part is only learning that. So now you've learned that. The next couple of days hopefully won't be that bad for you. All right. Now I'm going to hand back those tests, and that's all I have for the lesson for today.